So how do you actually teach a machine to understand language? And I don't just mean recognizing words, I mean getting the real meaning behind them. This is a puzzle that has seriously pushed the boundaries of logic and computer science, and today, we're going to dive right in and unpack it. Okay, let's take a super simple sentence. She saw that. For you and me, that's a piece of cake, right? But for a machine, it's a total logical nightmare. I mean, who is she? And what exactly is that? Is it an object? Is it a whole event that just happened? Without more information, that sentence is basically a black hole of meaning for a computer. And it really all boils down to one single crucial word: context. You know, we humans are like context superheroes. We fill in all the blanks automatically, without even thinking about it. But a machine, it has to be explicitly taught how to do that. And that's where our story really gets going. So here's what we're going to do. We'll start with the puzzle itself, then look at the really clever situation solution, check out the amazing toolkit it gave us, see it all in action, and then, gaze into the future of meaning. All right, first up, let's really dig into the problem here. Why is the way we talk every day such a massive headache for purely logical systems? So the thing is, the way we talk is just messy. It's flexible, it's packed with ambiguity, and it relies on this huge amount of unspoken shared knowledge between you and the person you're talking to. It's all built on this foundation of, you know what I mean, that never actually gets said out loud. And that is the polar opposite of how traditional logic works. In that world, everything is perfectly precise. A statement is either true or it is false. 1 or 0. There's zero gray area. No, well, it kind of depends. It's a rigid, binary system, and it's just fundamentally at odds with how we actually talk. So that's the big question, right? The challenge that researchers have been banging their heads against for decades. How in the world do you bridge that massive gap between our messy, fluid human language and clean, pristine, formal logic? Well, the answer required a totally new way of thinking. And that brings us to the breakthrough idea, the situation solution. This concept was a total game changer. The idea was brilliant. Instead of trying to fight how messy language is, why not just build a model of the mess itself? So, this whole framework is called situational semantics, and the core idea is pretty profound. It says, hey, let's stop asking if a sentence is universally true, and let's start asking, in what specific situation is this sentence true? It takes context, the very source of the problem, and turns it into a formal, even mathematical part of the solution. So this framework doesn't just treat situation as a vague idea. Nope. It treats it like a real, concrete thing with defined parts. You've got your set of events, a way to put them in order, a way to map them. But the real magic, the secret sauce, is that last part, the satisfaction relation. This is the formal test, the little engine that asks, okay, does this sentence actually hold up inside this one specific situation? That's what connects language to a specific context. And this quote really nails the massive shift in thinking. A sentence like, it's raining, isn't just universally true or false. It characterizes a specific situation, like the one happening right outside my window. It's probably false for the situation in the next town over. See, language describes a context. It's not just shouting out some global truth, and that is the key to everything. Okay, so once this foundational idea of situational semantics was in place, researchers could go to town. They could start building this whole new toolkit of specialized logics, each one designed to tackle a different, tricky piece of the language puzzle. One of the most important tools in this kit is something called non-Fregean logic. Now, for ages, classical logic, based on the philosopher Frege's work, basically said a sentence is just a label for true or false. That's it. Non-Fregean logic comes along and says, no way. It argues that a sentence refers to something way richer, the actual meaning the situation is describing. And what this new logic lets us do is pretty powerful. So now we can formally say that a sentence like, the dog chased the cat, is literally the same as the cat was chased by the dog. And why is that? Because they are both describing the exact same event, the same situation. For the first time, logic could compare real meaning, not just simple true or false values. And believe me, this toolkit is pretty impressive. You've got episodic logic, built specifically for AI to understand stories and events as they unfold over time. There are even logics that try to formally understand metaphor. I mean, can you believe it? Something that was once considered totally impossible for a machine. And you can even combine these tools to get the best of all worlds. All right, I know this could all sound a little abstract, so let's get to the payoff.
How are these logical systems actually being used to solve real-world language puzzles right now?
Okay, first up, a system called Multinet. You can imagine it as building this rich, multi-layered knowledge map from any piece of text. So if you're trying to build a question and answer system that truly gets what you're asking, instead of just matching keywords, a tool like this is way, way more powerful than the old school logic.
Or how about this? This one's really cool. Think about a simple word like suddenly. He stood up versus he suddenly stood up. That one little word completely changes how we picture the event, right? Well, systems like this one can formally model exactly how those adverbs shift the meaning of an action, treating it as a direct result of the context.
And it's not just about understanding statements. What about questions? A framework called inquisitive semantics actually models the logic of asking a question. This is absolutely crucial if you want to build an AI that can have a real conversation with you, a real dialogue, not just, follow a command.
So, after all that, where does this leave us on this huge quest to crack the code of language?
If there's one big thing to take away from all of this, it's this. For machines to ever really get human language, logic itself had to change. It had to evolve. It had to be stretched and expanded and completely reimagined.
Yeah, we've moved way beyond a simple black and white world of just true or false. The name of the game now is modeling the rich, complex, and often messy context that gives our words their real meaning.
And that leaves us with one last kind of mind-bending question. All the work we've talked about today is the foundation. So what really happens when machines can finally understand not just what we say, but what we actually mean? That's a future that's, well, it's both incredibly exciting and pretty profound to think about.